Today I'm going to tell you how to get critical information from an element symbol on the periodic table. And we're going to need this information to do a lot of things in the chemistry class throughout the year. So we are going to spend some time today learning how to acquire the information that you're going to need to do calculations and understanding of trends and stuff like that on the periodic table. So if you look at your periodic table, which I've handed out to you in class, you should see that it's a grid of a bunch of letters. Some have there's only one entry per box, and some have 2 letters per box. And then there's a series of numbers associated with each letter box combination. So the only thing that's required on a periodic table to make it useful is the following: the alphabetic abbreviation, or the letters that represent each element symbol, and the atomic number. Everything else is, quote, optional, right? Now, that's kind of tricky for us because we're going to use the periodic table as a tool. So what we're going to always have in our periodic table is its atomic mass and the full element name. So the periodic table that I handed out to you has these 4 things on it right here: atomic number, alphabetic abbreviation, atomic mass, and full element name. Some periodic tables have all this additional information, and the more information that you have, the more useful as a reference tool it can be. But for nearly 90% of the things that we need for chemistry for the high school student is found with these 4 things. Okay, your periodic table should have each element entry set up the exact way I have here listed in the video. You should have a number in your upper left-hand corner. You should have a set of letters in the middle of your square for each element. You should have a number here. This number should be smaller than this number, as you can see. And then you should have the word or the name of the particular element in each square. So the way these are set up for moving forward for the class is going to be the same. Each time that we talk about these numbers and letters, the orientation or the location of them is always going to be the same on your periodic table. So we will only use one periodic table to not confuse you. But as I mentioned before, the periodic tables are not set up with any standardized format, and so therefore, to keep things simple, we're going to use this format for the rest of the class. Okay, so your periodic table has an element symbol set up the same way as this one. The only difference is that the numbers and letters here are in different colors, whereas on your periodic table they're in one color, black. So, but the only reason I put them in different colors here is to highlight the locations and their things. So let's look at the first one. First one is what we're going to call our average atomic mass, or our atomic mass. And that basically is a weighted average of all of the masses of the isotopes that make up that particular element. Now, we're not going to go into the detail of what an isotope is in this particular video, but this basically is the mass of the copper atom, for lack of more detail than that, right? So again, this is going to be the larger of the 2 numbers that you see listed here, and this basically just represents an average mass in atomic mass units, which is the units here, of 1 atom of copper. Our next thing here is the chemical element symbol, and that's always going to be a combination of 1 or 2 letters. Every element symbol has at least 1 letter. Most have 2 letters. If it does have 2 letters, the first letter is always capitalized. The second letter is always lowercase. If it only has 1 letter, the letter is capitalized. So let's give an example of elements that only have 1 letter: oxygen, sulfur, fluorine. Oxygen would be O, sulfur would be S, fluorine would be F. All those would be capitalized when we write them down on a piece of paper. Copper, as you can see here, has 2 letters. The C is capitalized because it's the start of the element symbol, and the U is lowercase, right? So capital and then lowercase for 2-letter symbols. Single letter, all capital. Atomic number. That is the number of protons in an atom of copper in this particular case. The atomic number is the same for each atom of a specific element. In other words, every copper atom has exactly 29 protons. If I add one more proton, I no longer have copper, I have something else. If I subtract a proton, I no longer have copper, I have something else. So every atom that has 29 protons is classified as a copper atom, no matter what it weighs, right? No matter what its atomic mass is. The protons define the element. The number of protons define the element. Think of it as a fingerprint. Your fingerprint is very unique to you. My fingerprint is very unique to me. If we were to try to if we put our fingerprints on a piece of paper, I could identify which is you and which is me just by our fingerprints. Same way here, we can identify what the element is by the number of protons, right? Now the key is here that you do not mix this up with this. This number is unique to each element. This number is not as unique. Remember, this number is just an average of a series of atoms that may or may not have different masses of copper, right, based on their isotopes. So the rule of thumb I always tell is the atomic number is always the lower or the smaller of the two numbers. So when in doubt, if you're confused of which one is the atomic number, look for the smaller number on your element symbol. And the last thing is the element name. And the element name is just basically a word that describes what element you're talking about. It is used when we write out documents, text, and all that stuff, typically in non-scientific journals, right, for the layman or the average person, right? The average person hasn't memorized the periodic table and all the chemical and all the elemental symbols, but they do know what copper is and what zinc is and what aluminum is. If you write it out, they may not know what the element symbols are, right? As you get further into a scientific career, if you go down that pathway, some periodic tables that you work with do not have this name on it. Do not have this name on it right here. They expect you to know that, right? But for the new science students, which you are, the names are given for each element on your periodic table, because not all names represent or match the first letter or the chemical of the element symbol on the periodic table. Case in point, potassium is represented by the letter K on your periodic table, but the name starts with P. Sodium starts with a S and O, but the element symbol is Na. So if you're looking for something on the periodic table and you're trying to find where silver is and you don't know the chemical symbol, look for the word silver and then find the chemical symbol. If you're given a chemical symbol or an element symbol like this, you just find that on the periodic table and then you can translate it to the word, right? So that's pretty much it in a nutshell. There's not too much details on it. Again, the critical things are here is that you don't confuse these two numbers here, the atomic number and the atomic mass, right? Periodic table is arranged by atomic number. The atomic mass is really irrelevant. If you look on the periodic table and you go up and look all atomic masses, there are several cases where the atomic mass of an element that should be heavier is actually lighter because of the number of protons and such. So again, do not confuse these two up. I think most students confuse those. Okay, so if you followed any more of my videos, you know that at the end of each video or each little component section, I have you take a little mini quiz, and this is no different. So I've given you 9 questions here, or 8 questions, or whatever they are, and I'm asking you to use your periodic table, the one I've given you, and to complete these questions and answers. This should take you no more than a few minutes, right? And when you're ready, you're going to stop the video, answer the questions, and then when you're ready for the answers, start the video, and I'll go over the answers. So when you are ready, stop the video, answer these questions on a separate piece of paper. When you want the answers, restart the video. So stop the video now. All right, so I've given you the answers. They should be pretty straightforward if you followed all your notes and used this. If they are not, you should see me or your teacher to discuss further, but it should be pretty self-explanatory if you followed along on the lesson, and we'll go from there. Again, the critical thing is not to confuse the atomic number with the mass number. If you can do that and you know the location of that each time, everything else will fall into place eventually. So again, takeaway, do not confuse atomic number, which is the number of protons and unique for each element, with the atomic mass.